Hello and welcome to my Lab 1 physics video. So the goals for the experiment were to observe and analyze an object concluded to be moving with constant velocity and to create a model of this based off of the data gathered in the experiment. The general results of the experiment were that the object was concluded to be moving with constant velocity, and we successfully created a theoretical and experimental model of motion with constant velocity to represent the data collected in the experiment. So the fundamental equation for this experiment was Newton's second law, which says that the sum of all forces acting on an object is equal to the product of its mass and the rate of change in velocity, which you can see with the variables in units right there. Mass will be kept constant in the experiment as we're only using one object, and then constant velocity implies that acceleration will be zero, which thus means that there will be no net force. And this equation is useful as it helps to relate variables in a simple way since we're able to eliminate a lot of the equation given the nature of the experiment. So a computational model was created using GlowScript and Python, and it allows us to recreate the experiment in perfect conditions and reduces sources of error. It also gives us a good base to compare our experimental model to. The experiment captured a video of a ball rolling across the surface with constant velocity, and this video is modeled and analyzed using Tracker, which allows us to more accurately analyze the footage to extract the most useful data in our comparisons and analyses. So in the experiment, the system was the tennis ball I selected to roll across the table, and the surroundings were the table itself, the air surrounding the ball and the table, as well as me. And then that's the face when you move with constant velocity. The experiment process, I selected a ball and I recorded its mass and diameter. I set up the camera to capture video, and then I set the ball at one end of the table and rolled it from rest, and then I uploaded that video and analyzed the motion of the ball and extracted data. I used data obtained from the tracker analysis to create a computational model of the experiment in GlowScript, and then I compared these models and made further conclusions. So in Tracker, I trimmed down the video so as to allow the ball to get up to speed and remain in constant velocity, which you can see on the model that I created in Excel. You can see that the position I chose to be in the negative x direction, and then when plotting it against time, you can see a directly proportional relationship, thus indicating that there is constant velocity for the ball. In GlowScript, you can see a similar relationship being displayed. The velocity for this was calculated using both data collected from Tracker as well as the rearranging of the FNet equation. I rearranged it based off of the following to isolate the final velocity. You can see that right there. I calculated the initial velocity based off of the equation for velocity, change in distance over change in time, or change in displacement. And I uploaded that as the initial. And then comparing the models, you can see that they both follow very similar paths in motion, and they both demonstrate a linear relationship when plotted against time. They're both moving in the same direction, and they both demonstrate motion with constant velocity. Some differences that you can see is that the tracker begins to slightly less change in motion towards the end of its trajectory compared to the GlowScript coded relation, which leads to a slight difference in slope for both of them. You can mainly see this deviation between 0.8 and 1 seconds on the graph. And then this leads us to our discussion of error. So little random error was seen throughout the experiment as a lot of the computation was done through computation through the computer. So there was likely little human error in the collection of data points, but there could be some in the selection of the origin and center of mass. And then the ball also began to slow as the trial progressed due to an unaddressed rolling friction force, which would have caused that change in points towards the end of the experiment like we discussed earlier. And then as for systematic error, the ball was not exactly at the origin at the start of its motion, which caused a systematic shift error in the graph as it should have passed to the origin exactly for both graphs. The what if for the experiment would be what if we change the positive and negative x-axes for the motion. So movement to the left would now be in the positive x direction, which when plotting it against time would mean the position would be in the positive y direction. You can still see that a direct linear relationship is demonstrated between the ball and time. And not much else would really change, except for that you can see that there's now a positive rate of change between position and time. So for what does it mean, you can see that gravity and normal force are both constant forces that are acting upon the ball, and even though it was neglected, there is rolling friction acting upon the ball opposing my pushing force, which I enacted upon the ball, pushing it in the negative x direction. Each force cancels out its opposing, seeing as the data does demonstrate a directly proportional relation between position and time, indicating constant velocity and thus zero acceleration and net force.